Hello, everyone. Thanks for joining us today. This is, I think, our third tech seminar. And today what I'm going to do is talk about the path statement, which I think all of us learn new things about all the time, including myself. And it's really fundamental to understanding the way AscentialTest works. So I'm really going to start with the basics, but I'm going to take you into some really interesting implementations of the path statement. And I've borrowed from various customers that I've supported, over the last few months. So things that I have thought were interesting, I would reach out to customers and say, hey, can I use this example? Because I think it's going to be helpful to others. So thank you all, also those of you that have agreed to allow me to share your examples. So I'm going to start out explaining what the path statement is. And I will talk about how it actually works, because I think at least some of the time I don't even think about how it works. I just assume it's going to work, but we'll talk about how it actually works. I'm going to cover the basics, which may be refresh for some of you, and then I'm going to go into some advanced path statement techniques and show you a lot of examples. And as Sandra said, at the end, we'll have plenty of time for questions and answers. So the first thing I want to talk about is, what is the path statement? Well, along with the object class, the path statement is used in AscentialTest to identify application elements. So if we look at our little example here, you can see that the object class of this element is a web text field. And here is an example of a path. And of course, this path is using an attribute. That's why we see the little @ sign here. So by itself, the path statement wouldn't identify the object, because we also need to know the class. So the object class and the path are used together in AscentialTest to identify the application elements. Now, how does it work? Well, AscentialTest uses this object path and class statement to look for elements that match. And so when you take a snapshot, when you're defining your objects, we're using the snapshot that you took to look for matches of the object class and path. But many of you know that at runtime, we're also taking snapshots. We don't save those snapshots unless there's an error, and then it's going to be presented to you in the results file as an error snapshot. But we're taking hundreds and thousands of them actually and throwing them away. Anytime there's a change to the application state, we take a new one. And so that's how we're looking for objects, through snapshots, either in AscentialTest itself, when you take a snapshot manually, and then you're doing your dragging and your dropping, or at runtime when we're taking these snapshots. And so what we're doing is we're looking for matches, and a list of matches is returned. If there's more than one match, then we get a non-unique error. If the list comes back empty, then we get an object not found error. It's only when a match occurs with one match that we get the green check mark. So we're going to look at an example now. A couple of examples, actually. So here's a picture of AscentialTest, of course, and you can see that in this case, we have an object class and a path that match more than one object. Now, I did that on purpose for the example because there is an address 1 and an address 2 here in the snapshot. Well, I simply changed the operator from equal to like, and then I put an asterisk in. We're going to be talking about all these techniques in a few minutes. So I purposely allowed this particular definition to match more than one object so that I'd be able to explain it to you. And you can see very clearly, we tell you 2 objects are matched. The path is not unique. Now, can you leave it that way? No. That's why we're indicating this with red and telling you the paths are not unique, because if you left it like this at runtime, when you tried to run a test and put text, for example, in one of the address fields, we wouldn't know which one to put it in. And so we always have to have a green check mark or a green number. We'll talk about that a little bit later as well. Whoops, did I go? I want to make sure I didn't skip by another example. Let's see. Okay, I thought I had another example of, let me just back up, of a not found. Maybe not. Okay, I guess not. Oh, there we go. There's the object not matched. So here's another example. So we have the web text again, and we have equal address, and you notice that I took off the 1 and the 2 again to make sure that this doesn't match, so I have an example for you. Now here notice that there's not a green check, there's a rectangle, it's red, with a minus sign in it, and the message says no object matched. Can you leave it like that? No, because if you do, at runtime, when you try to put text in this text field, AscentialTest is going to say that the object is not found. And we'll take a snapshot actually and put it in the results file, and you'll be able to see exactly what we're looking at here, minus my red arrows that I painted on here in order to direct your attention. So we've talked now about the non-unique, where matches more than one object, and the object not found. Now let's talk about the basics. In these basics, a lot of them you sort of learn just by drag and drop, because AscentialTest uses these types of path statements a lot. So we see attributes being used, and when there are attributes, sometimes we want to say equal, meaning we have to have an exact match, or we can change the equal to like, and then put in some wildcards, and we'll talk about that in just a little bit. You also see contains a lot. Contains is where we're using children of an object in order to identify it. We're going to look at examples of all these things. Relative location. That's another one that you see used a lot. Left of, right of, above, below, overlap X, overlap Y. And then of course the index, which is sometimes used alone, but more often with other paths. So let's take a look at some examples now. So the @ operator indicates that we're using an attribute. And you know that these attributes come from the attributes panel, which is located just to the left of the snapshot, right? When you think of the snapshot, I know we don't have a picture of it in front of us here, but when you think of a snapshot, you have the snapshot image on the right, you have the elements upper left, and then lower left, you have the attributes panel. And so that's where these attributes come from. And again, we use the @ operator to indicate an attribute. And here's an example. We are looking at a Power Builder application, obviously. It's a PB compute field. And that's the class of the object, PB compute. And then we see the path starts with the @ sign, so we know this is an attribute. So @ sign object name equals order total. So in this case, it has to match exactly because it's equal. And for you Power Builder users, you know that this is a very typical path. In Power Builder, we almost always use the object name when it's available because it's a good solid path, unlikely to change. And I didn't mention this before, but when we're choosing paths, and when AscentialTest chooses paths for you automatically, we're always prioritizing the paths that we think won't change when the target application changes, right? Because we want to reduce the amount of work or the maintenance that we have to do. Now let's look a little deeper at attributes. I mentioned already that normally attribute is equal, but we can change it to like. Equal has to match exactly, whereas Like can be used with wildcards, a question mark to replace a single character, a star or an asterisk to replace multiple characters. Now here's a really typical example of how this would be used. I think a lot of you have probably found that when you drag over, say, the main window of your application, sometimes there's information in the caption of your application that is variable. It might even be the version of your software or the date that it was released, or sometimes it reflects some data that has been actually selected in the application. And so when you did your drag and drop, that information probably came out as part of the path statement because it was part of this caption. And so in a lot of cases, you need to go in and change the equal to like. Notice like is all lowercase, and you'll notice that it turns blue when you get it right. If I had an uppercase like in here, it would not turn blue, it would be black, and that would kind of be a visual clue that I didn't quite get it right. And then here you can see that the asterisk was used along with the like to make sure that this path is always going to match even when the variable information after the word cascade is displayed. Contains, that's probably the second most used type of path. This is where we're identifying the object based on some element that the target object parents or contains. So for example, here is something called the Report Manager Win charts. And it has some children, including the charts heading. And so you can see here in the path statement, we're saying, well, the charts object has a path statement where we're using the caption equaling Report Manager, but it also contains the charts heading. Now, why would we do that? When Reports Manager would work just fine at identifying the object. The problem is, and some of you might see this in your applications, some applications, the caption is actually the same for every single object or every single window in the application. Now, would AscentialTest work and identify the objects in that case? Yes, it would. However, it wouldn't really be able to distinguish one page from another. So if you're in that situation where you know that your caption is the same, and one way to know this right away is if you open up a snapshot and you look over at your app objects on the right, if you see like a whole bunch of green checks, that's not a good sign. That means that your top level window paths are not unique. And I really strongly recommend in those cases that you always add this little phrase here where you say comma, contains, and then pick something in that particular window, in the charts window in this case, that is unique. Because it will make AscentialTest work a whole lot better in terms of synchronization. It will know when the page isn't present, like when you do a wait until exists. Well, if you do that and the page that you just left has the same caption as the page that you're going to, well, it might not work so well. You really want to have good, unique paths for your top level windows, and contains is the way that we do that most of the time. Relative location, this is another one that is used quite frequently. This is where we're identifying an object relative to the location of another object. Now, there's no absolute locations here, so this is not a bad path. This is a good path. Here you can see that we're saying that this particular object, in this case a PB table called items, is below this text. Now I want you to notice something a little different here. Whereas with contains, if you think back of what I did, I actually referred to an object that was defined. So in that case, I said contains, and then you might have noticed the angle brackets. It's not easy for me to go back and forth, or I would show you, but I'll try to remember to show you later. Whereas here, I maybe didn't define this object, state zip, but I don't have to define it because I could say it's below PB text with the attribute state zip. Really the same thing. And you'll notice that these aren't always paths that you have to construct. In many cases, AscentialTest will come up with them as well. In fact, you can see that here in the app paths. In fact, AscentialTest gave below PB text state zip a higher grade. You see it got a grade of the letter A, whereas the visible objects got a grade of the level of the letter B. I'm not a real fan of using visual objects, by the way. I do when I have to, but I'm always looking for a different kind of path instead. Now, index. Index identifies an object based on its relative location to other objects of the same class. And the index is oriented from the upper left down to the lower right. So if we had a whole bunch of text fields, the text fields, say over here, would be 1, the one below it would be 2, or the one to the right of it would be 2, because we're going, again, in this direction, from upper left down to lower right. And we just assign those indexes based on the object class. Now, sometimes you might see a path where it's just an index. Excuse that, I'm going to turn the volume down on that. But normally, the element class, the index is used with some other type of path. Like in this case, we're using an attribute and we're using an index. Well, why might we be doing that? Well, the reason might be that there is more than one object in this case with the same element class. So in order to distinguish them, I added the index. This is the first element class caret RC dash anchor dash PT, or there could be a second one or a third one. So that's the use of the index there. Do you use it alone? Sometimes, not often. So here's our note here. The index is often used with other paths. Okay, so those are the basics. Now I want to talk about some things that I think are a little bit more interesting. We're going to talk about match, which maybe some of you don't know about. We're going to talk about grouping. We're also going to talk about scope. And then I'm going to talk about some unusual path examples. So I'm going to show you some really tricky paths. Now, you've probably noticed up at the top of your snapshot, there are these 3 checkboxes: ignored, hidden, and clipped. By default, when AscentialTest creates a snapshot, we purposely ignore some of the objects because there are objects that we just know based on our algorithms that aren't really necessary for identifying an object most of the time. So we don't even include them here in the elements tree because we want to simplify this for you. It's complicated enough. So we get rid of anything that we think is superfluous or unnecessary. But sometimes we make a mistake and we throw something out that you really do need. And the way to get it back in is to just check ignored, and then you will see it. And you notice ignored is shaded in this color here. I'm never sure what to call this color, but it's shaded. Sometimes the developers actually hide an element on purpose. And so it's got an attribute, a hidden attribute. Well, by default, we don't show those because we're trying to show you the snapshot as the user sees it, but sometimes you want to see those objects, particularly for verification. So you can check that checkbox and then the hidden elements would show up. Clipped are things that are obscured by other objects. This is sort of rare. Don't really see this very often, but the other two see frequently enough. Now, how do you use that? Well, there's a match. Maybe you don't even notice it. There's a match field at the end of the path here. And if you click the little arrow, this drop down will show up. And there are 3 checkboxes to correspond with those 3 checkboxes that I talked about earlier in the snapshot: hidden, ignored, and clipped. If you want to identify with your path an object that is hidden, ignored, or clipped, you must check off the checkboxes associated with those particular attributes. If you don't, even if you've got the path right, we won't match it because we won't look, even at runtime, we won't look for those particular objects in the hierarchy. So you must do that if you're using an object anywhere in the hierarchy that's hidden, ignored, or clipped. Now, the tricky thing about this, and this is an example, this is a real example, and Rajneet, if you're here, thank you for allowing me to use your example. This was a good one. This particular application had a very deep hierarchy, and most of it was either hidden or ignored. And so in order to identify the object, not only did we have to check off hidden and ignored, but you have to include in your path statement, you have to go all the way back to the first element that was either hidden, ignored, or clipped in order to get it to match. So this was a little bit of a trial and error, but we finally got it, and there were actually a couple of objects like this in the application. So again, this was a very tricky path, but it is definitely doable if you understand hidden and clipped. Now I want to talk about grouping. Groups are used to collect objects. Group is used to collect objects into a single object. Now this is distinct from group by, which we're going to talk about in a few minutes. I'm talking about just group right now. It's often used, I think the way you see it used the most is when you want to form a table header. And I'm going to show you an example in a minute. In order to expose this part of the app object editor, you have to check on advanced options. And then this little section down below shows up. Remember, if you don't check it, you only see the top part here. So if you check advanced options, the bottom shows up, and you'll see under group type, one of the selections is all. And so if you want to form a header, and I'm going to show you the example now. If you want to form a header, that's exactly what you do. So if you look at my example here, you can see there's a header to this table: track, artist, song, score, album, bitrate. Well, I want to form one object, the header. And to do that, I can say that these objects, they're all render text, by the way, in this particular example. These objects share, excuse me, a vertical order of 1. So it's the first row, basically, of the table. And so they share that particular attribute, the vert order. But in order to see them as one object, I say group type all, and that groups them into something that I can then refer to as a header. And then I can simply take and drag and drop the rest of the objects underneath the header. Do you have to do that? No, but it's kind of convenient because then it groups the different header elements into a single object. making it easier for you to refer to those, because maybe you're going to use those header objects to define the actual columns in your table. So that's a very typical way to use group. Now I want to talk about group by, a little bit different. Also related to tables and grids though a lot. So group by is often used to form the rows in tables and grids recognized by render text. That's not its only use, but it's probably one of its most frequent uses. So we're going to use it with either an attribute or an integer. Excuse me. Right now I'm going to use the attribute, but I have an example later on where I'm going to use an integer. So you can see in my definition here, I've checked on my advanced options so that I can use the group by attribute. Let's look at an example. So here I'm forming a row. Again, by the way, this is render text. So you see that the rows are formed by render text. Now, I'm excluding the first row. Why? Because that's the header. It's not part of my table. So this is the table formed by render text where the vertical order is greater than 1. So we're excluding the header. And we're grouping by the attribute vert order. So that's what actually forms our rows. So what that means is that any of the render text elements that share group by, they share a vert order, that defines a row. That's how we kind of make sense out of all of these pieces of render text. We're saying all the ones that have the vert order of 2, well, we're going to call that row 1. 3, we're going to call that row 2, because remember, we've excluded the header. So very useful thing to know about when you want to form tables where there's not really a table. Now, do you have to do this in .NET? No, because there's a real table there. Power Builder? No, there's a real table there most of the time. Sometimes we use render text when we've got groups and things like that. On the web, yeah, sometimes the table wizard will handle this for you most of the time. But render text, you often have to do this on your own. So it's good to know about this. Now let's talk about the scope. I think maybe out of all the things I've talked about so far, this one is the least understood. Scope is telling AscentialTest, what is the scope of this match? And I'm going to show you 2 different examples. The tilde, that's this little squiggly character here, with the slash is a wildcard for 1 or more element nodes. And this is not unusual. Anytime you have an application that has an MDI and you do your drag and drop, you're going to see AscentialTest come up with this path. You don't have to do it. AscentialTest is going to do it. And you see what we're doing is we're saying, here's the top win. It's the main window. Now there may be some number of nodes in between. So we say tilde slash, and then the thing that we're defining, and in this case we're defining the MDI child, master table maintenance. We're defining that, and here it is right here, lit up in green. But in this case it only has 1 node in between the top win, but sometimes there's more. So to be safe, when we do the drag and drop, we always put the tilde slash in there. That means no matter how many nodes are in between the top win and this MDI child that we're defining here, doesn't matter, we're going to match it. Now you notice I didn't put MDI child in front of the square bracket here. I could have done that, might have been clearer, but it is, we are defining an MDI child, so it's not necessary to put that there. Now this one's tricky, and this is a really good thing to know. I get fooled by this myself every once in a while. The slash actually restricts, remember, not the tilde slash, just a slash by itself. It restricts the match to direct descendants. Now I'm going to explain the difference here. If you look at the difference between my two paths, it's really subtle. They're both WebLM, right? Both sidebar. These are two different definitions for the same thing. One that does not work and one that does work. When I first did this, I put web block. It's a web block, right? And it contains the web text like if you're interested. And here's the text right here, and here's the if you're interested. I used a like with a wildcard because I didn't want to put the whole thing there. Okay, this is our sidebar, by the way, in the old website. So that didn't work. And there's a good reason why it didn't work, because you can see that there's web block text. Well, if I just say that it's the web block that contains the text up here, web block that contains the text, well, that could be this one here, because this web block contains the web text, not directly, but it does contain a web text that has this text, or this one, which contains the text. So you see the confusion here. Do we mean this one or do we mean this one? Because they both actually contain this web text, but one directly contains it. That's the one I'm trying to define. And so by adding the slash here, now we're saying this is the web block that directly contains the web text at text like if you are interested. So that gets us out of the problem of the non-unique. So again, this is a really good thing to know about and understand. Okay, now I'm going to take you through some kind of unusual examples, and I'm going to use a live AscentialTest to do this. I'm going to talk about how sometimes when we use contains, we use contains when the element class is not reliable. Excuse me. And what I mean by that is sometimes you'll have applications where the element class is generated by some tool that you're using to render your application. So when you see an element class that has a bunch of letters and numbers in it, that doesn't really spell out what the object is, it might not be reliable. What I mean by that is every time you regenerate the application, every time you do a new build, the path might change. So you don't want to use a path like that. I'm also going to talk about how you can use multiple paths to define a situation where you have a form sometimes, or you have a table at other times, but you don't want to have two definitions. And then I'm also going to talk about a really interesting use of group by with count. I showed you group by with an attribute, but I didn't show you group by with count. And then finally, I'm going to show you an example where you have to form a selector with a path that does not have the word contains in it, which is not typical. So we're going to look at that as well. So let me switch over to AscentialTest now. Okay, so the first example I want to show you, let me get my snapshot. Again, thank you for to loop testing to allow me to use this example and their customer as well, because this was a doozy. So Matt, I hope you're watching right now. Here's a situation where we've got an application that's, again, I think using something that's going to be generating these objects. And notice that the paths have these element classes that have, lots of letters in them that don't really spell anything. They don't really make any sense. That's sort of a hint that maybe these aren't going to be reliable paths, because when I get a new build, maybe they're not going to be the same. And I think that was the case here. And that's why I couldn't just use the elements. So what do? Well, one thing you can do is you can look at the structure itself, because there's just a bunch of web blocks here before you actually get to the thing that you want to define. In this case, we wanted to define a row in this table here. Let me just, I can make this a little larger so you can see that it's a table. It's got rows and columns. And so what we came up with is using contains many times. So we say, here's the block that contains the block that contains the block that contains the web text. Now, were there other ways to do this? Yes, we probably could have used slashes and maybe tilde slashes and things like that. But this was a really good, reliable way to define this table in a stable way. So even though you get another build, you get another build, this type of a path is likely to continue to work. I want to just look at my notes here to see if there's anything else that I wanted to tell you about. So I can show you the selector. And we've got a couple selectors here. Notice that the selector also uses contains. But if I put in 41 star, you'll see our selector does work just perfectly. It selects the row where we have 41.mp4 here. So that was a pretty interesting use of contains in order to not only form the row, but also to form the selectors as well. Now I want to show you another example. And this one, another interesting one. Here we've got a situation where notice that this is a table right now. We're looking at a table, but we're also sometimes looking at a form. So you see a PB form here, whereas if you see this one, there's a PB table. So it just depends on whether or not there is one row or more than one row. So if there's one row, it's a form. If there's more than one row, it's a table. Well, this customer didn't want to have two definitions and then have to put an if statement in there, to branch their actions. And so they asked me, and this was interesting because prior to really playing around with this, I didn't know this was possible. I think in the past I might not have come up with this solution, but I've saved it now and I've given it to other people who have asked about it because it is possible by using the multipath. And notice I've got two paths here. Multipath just means I put my cursor at the end of the row and I hit enter and I got another row. So the path isn't necessarily only one single statement, it can be multiple statements. So in this case, I said, well, okay, if it's a PB form, and watch if I switch. Let's see, where's the PB form? Oh yeah, got to click off and on, I think. So the PB form, you get the one here. So you know that it's, when you see more than one path, if you get the one here, you know that that's the path that's actually working right now. The other one has got a green rectangle with a dot in it. Well, it's not matching, but it's actually not being used. This is the one that's being used. Whereas if I switch back here, you see that the 2 shows up here. Is it a problem that it's a 2? No, because it's a class and it's matching more than one row. So this was kind of tricky, and what you might notice is that I didn't define a table. Notice that the class, this is the row class. There's no table, because if I put the table in, then the form wouldn't work, because the form's not a child of a table. So that was the real trick, and I think that was the thing that escaped me the last time I tried to solve this, was I defined the row without its parent container, which is usually a table. And so it's really just owned by the dialog box itself, the way I defined it. So I've got my dialog box, or MDI, or main-win, it wouldn't matter. And then I have my row as directly, this is a row here. I'm treating it as a row, but it's really a table. Notice the path, table that contains the row that has the column. So that's how I'm differentiating it, and then I'm really defining the row. So in a sense, there's no table here. I'm really defining a row, but it's a row. When it's a PB form, it's really just one row, whereas if it's a table, it's more than one row. So this was very tricky. And again, I've saved it. If anybody ever needs this, you know who to come to. I will be able to share this with you if you need it, if you forget about it. Let's see, I can, just looking at my notes again. Okay, I think that's all I wanted to show you on that one. Now, I've got another example here. Also very tricky. And this came in handy last week. I've done this several months ago for a customer, but another customer needed it last week, and I was like, yeah, I know how to do that. So I was able to give them a really fast example on how to do this. This is a very, very interesting problem. It is a tree view of sorts, but it has checkboxes in them that are not real checkboxes. So you can see here in the tree, this one happens to be a WFM tree. I think the one we did the other day was regular tree view or a power builder tree, I forget. But it's just a WFM, so .NET WinForms tree view with a bunch of items. And the items themselves are pretty much normal. You know, what's not is it's the checkbox that's not really a checkbox, it's just a graphic that's sitting there. Well, you need to know sometimes whether it's checked or not. So you can't just select it and say hit the space bar, because what if it was already checked? Then you've just unchecked it. So you need a way to know whether or not the box is checked or unchecked. And so, again, very tricky. The way we did this, and I learned this, by the way, from someone else in our company. I did not come up with this one the first time. So here's our row, and our row is actually defined by render image, because that's how we decided to define these boxes. You can see here, I've got two render images. I've got the box unchecked, and then I've got the box checked. So I've got two different images, checked and unchecked. So this row is defined by render image and item. Now don't worry that we don't see all the ones, the render text, the render image is only going to see the ones that are there. So you have to have a scrolling mechanism if you don't see it. But that's not really a big deal here, because it'll scroll automatically anyway, because it sees all the items. So you really don't even have to worry about it. When you go to select, it'll scroll it into view for you, because again, it's just a regular tree view. So we've defined the row that way, and you can see there are 13 items, and there are only 6 checkboxes visible. So you see the 6 checkboxes, and again, don't be concerned that they don't match. That's okay, because when it scrolls in, it'll see whatever's in view. Then we've got these select that will look to see whether or not it's to the left of a checked box or an unchecked box. So I want to show you how this works, and this is actually quite important. So if we look at this one here, we're going to look at unchecked, and I'm going to put in this value. And notice it finds a match, right? Because I'm using select unchecked by item checked. So it finds a match. Now, if I put in another value, like this one, you're going to see it doesn't match, right? Because right scalene doesn't have an unchecked box in front of it. It has a checked box in front of it. So these selectors are actually working, because it only finds the match if it's alongside the box that it should be along. And you can then use your wait until exists. And I had a note not to use is present in this case, to use wait until exists. You can check to see whether or not your item has a checkbox or not. And that's how you can then make the decision about whether or not you're going to hit the space bar in order to check it, or you could even click on it because it is render image. So you can use your mouse or your keyboard to actually make the selection. So you have a choice. You can actually select the row using the item and then hit the space bar to check the checkbox, or you can simply use your mouse and just check the checkbox next to the item. So again, another really interesting problem. And render image, along with our ability to form classes, the class of row, is what made this possible. Okay, I've got one more example for you, and then I'm going to turn it over to questions. So we'll have about 10 minutes left for questions. I want to show you, this is not that unusual. So here we have a situation where we have a page. We have a what I'll call a table, but it's a table of only really one row. And so I've got my row class, and you can see that it's a bunch of links. And that works out just fine. But if I want to select from those links, then I need a selector. And what might look strange to you, because folks that know selectors know that selector usually begins with the word contains. And whenever I describe it, I always say, find me the row that contains the web link where the text is like select by letter. But in this case, you can't use contains because the whole table is defined by those letters. So just something to remember when you have a table that you formed, not a real table, you formed it. It's really just a block with a bunch of links in this case. So if you formed a table by grouping things together, notice it's grouped by all, and so we group by, again, all, not a number. This was group, not group by group. And so we've used group. And so when we use group, if we want to select, we don't say contains. That's the only difference between the two. The selector's still going to work just fine. So if I put the letter B in there, notice it found the letter B, but it's not that it contains it, it is the letter B. Okay, so right on time, it's 10 of. We've got 10 minutes left for Q&A.